Okay, we're recording. Hey everyone, welcome to Bitcoin Insider Edition. I'm niftynei. I'm here today with Pieter Wuille.
Hello.
Peter, did I say your name right?
Close enough.
Okay, I feel like I struggle with even spelling it. Like, I was getting ready for Bitcoin and I get this DM from Peter and he's like, my name's spelled wrong on your website.
Oh, right. Yeah.
Is that common? Do people like usually
Yes,
mess
that
it
is
up?
very common.
Yeah.
Don't worry.
I appreciate the correction though.
We need to check some maybe.
Yeah, maybe. Yeah, so you're working on... So you work at Chaincode Labs.
Yep.
You've been there since you left Blockstream a few years ago.
Yeah, that was in 2020, I think.
Oh, wow. Really that long ago? Okay.
Yeah, though there was this pandemic thing going around at the time, so I only actually moved there in 2021.
Oh, okay, cool. And you like New York City? Been there a while?
Yeah.
It's a big city.
It's quite different from
the Bay Area.
The area.
Yeah, I'm familiar. But, okay, so you left Bitcoin, or you left Blockstream. Still doing Bitcoin stuff, right? So you're at Chaincode Labs now. And the project you've been working on at Chaincode Labs, you started working on a few years ago, right? It's something
2 years ago, I think, by now.
Okay, was it really 2 years ago? It's called Clusterme, right?
Yep.
And so, like, I remember there was a post. Was it Suha Software who put out a post on it? Or was that... Like, where did the idea for Clusterme kind of come from?
Well, it originated from a discussion between Suhas and I at Chaincode. And we were... I think he just gave a talk about some of all the ways that our current handling of dependent transactions in the mempool is just totally broken.
Okay, yeah.
And started thinking about approaches to solve that. And really the problem is we don't really have an ordering on transactions, so we can't compare and see how good one is compared to another. If a replacement comes in, we can't tell is it better or not. There are all these heuristics, but they're inconsistent, and we can come up with examples where they're just completely wrong. Like you can... I'll give the example tomorrow in my talk, but I think that the most egregious example is a case where, in theory, you could have a mempool where the very first thing you evict from, if the mempool gets too big and you want to want to make space, the first thing you kick out is actually the first thing that a miner would want to pick up.
And this is like how the mempool works currently, right?
Yeah.
Okay.
So
that sounds like a problem.
Yeah, and so while the Clusterme mempool project has grown in scope and all the things that we're trying to fix in it, and there are many nice side effects, like just being able to reason about optimal ordering of transactions all the time is what we'll practically be able to do. That was not the goal. The goal was just fixing this bug.
The bug being that if a new transaction arrives, we're probably going to kick out the one that the miners would want to include.
Not probably, but we can come up with pathological examples where that is the case.
Okay.
And it really works very short. We have one algorithm to pick from the mempool transactions that we want to include, like the highest fee ratings together with all their ancestors, and there's another algorithm for deciding what are the worst ones, namely ones with the lowest fee rate, including all their descendants. Whenever you kick something out, you need to kick out the descendants too.
Right.
Whenever you include something, you need to include all the ancestors too.
Right.
And this is nicely symmetrical, and you would think one does exactly the opposite of the other. Turns out this is not the case. And the real solution to this is we really need an ordering at all times of all transactions. And if we have that, then mining is just pick the first ones. Eviction is remove the last ones.
Right.
And they're might still not be perfect, but at least it will be consistent with each other. And I think more at zooming out a bit, because these details are probably too hard to talk about here, is it gives us a framework to reason about complicated things. Like once we identify this problem and the solutions for it, became apparent that there are all these places in the code base that try to heuristically decide, is this transaction good enough? Is this better than another? Like, of course, I've already mentioned block building and eviction, but there's also fee estimation. For fee estimation, you have a transaction with a dependent transaction. It should not be treated as its original one. Its fee rate is modified by the other one. So that's another example. Though fee rate estimation in Bitcoin Core is unreliable for completely unrelated reasons.
Interesting. Okay. Because I feel like we ran into this on Core Lightning. Like, we rely on the fee estimation from Bitcoin Core to figure out, like, how we should price, like, transactions.
The reason is that it's super conservative in a way. It was designed to not be vulnerable to problems like miners stuffing a block with apparent high fee rate transactions, because that would there's only so much we can do in a setting where it's automated without a human interacting with it and without a service being able to decide whether it's reasonable. Like, it's quite hard to design something that just is beyond influence of both mining, but also can suffer from problems like you're running an older version of the software, or just one that has somewhat different rules for transaction relay. And you have a transaction in your mempool that you think should be mined, but maybe a consensus rule has changed since, and that transaction is just invalid.
Right, interesting.
Are you gonna treat that as clearly miners are not picking this up, it doesn't have a high enough fee rate? No, it might be something else that's wrong with it.
Got it.
So there's all these concerns, and the current approach is based on seeing transaction enter the mempool, measuring how long it takes until they end up in a block. And anything that isn't both seen in a mempool first and later in a block is just ignored for that purpose.
Oh, that makes sense.
And it is purely based on historical data. So it doesn't react to the current mempool, as if there's a sudden influx of transactions. It won't react to that because it's only when those transactions start getting confirmed that there's
a tailing indicator to some extent. Oh, that's interesting. Okay.
And so there is work on this in particular. Abubakar Ismail is working on introducing a more general framework for having multiple estimators. And
that's cool.
One of the things you can do is, like, you can look at the current mempool, but maybe bound it by what you see elsewhere, and or measure, like, is what I have been seeing in the recent past been indicative of what goes into blocks? If so, maybe I can rely on it to some extent.
That's cool.
So so this is all just one. So fee estimation is another.
I wanted to kind of just explain, maybe for people who are watching, really quickly, the thing you were talking about, how one kind of attack on fee estimation that you want to try and avoid is miners can add transactions to blocks that are their own transactions that are paying what looks like a ludicrous fee, but it was their own Bitcoin that went into it, and it's going back into their own pocket. So the only thing that this costs them is block space.
Correct.
So, like, they're not getting the fees from someone else that might have. But if you get enough little transactions at the beginning of the block that look really expensive,
maybe this influences some people's fee estimators, which causes them to pay a higher fee, and maybe that's enough to offset the opportunity cost that they missed out on by putting their own transactions instead.
So it's a little bit of a play. So that's why, just as an example, this is why you're like, you don't want to use exactly what's in the block.
Exactly.
You kind of want some sort of heuristics, etc. Yeah, that's really interesting. And it's kind of interesting when you think about it, how many different vectors there are that you have to consider. Like this, like attack of like, oh, a miner could put transactions in the block isn't something that you would just naively think of when you're thinking of the mempool problem or how to order transactions. Yeah.
But so the result of this is that Bitcoin Core fee estimation is always lagging behind, in a way, doesn't react to changes very quickly. I think it does an okay-ish job if you don't want very short-term estimates.
Yeah.
Which are kind of dicey to begin with, because asking what fee should I pay to be in the next block is an impossible question to answer, because the next block might already exist and you don't know about it.
Okay. Yeah.
So
what's the number of blocks you could be like, I can't figure out what to be in the next block, but is it like next 2 blocks, next 3 blocks? Like, is there like a number of next 10 blocks in which you like, can make like a reasonable estimation?
Even the next 10 blocks, it's possible the next 10 blocks have also been mined already and you don't know it. But the odds for that bit drop off very quickly. It is just to say, I do think things would be healthier in the ecosystem if fewer people try to be in the very next block.
Interesting.
That would, but human nature.
Yeah, I mean, is there a way that, like, I mean, how would you change that? I guess it's like you need wallet developers to change what their options are. Do you think it's just people want to be in the next block?
Partially, I'm sure it's a UX thing, which I am certainly no expert at.
Yeah, that makes sense. Cool. I had another question, and I'm like struggling to remember it, about something you said about the mempool. Oh, so like, you know, when you're doing fee estimation, one of the things that I talk about kind of read a lot is like private mempools, or places where people are paying miners to get transactions into blocks with money other than what's represented in the transaction.
Out-of-band payments.
Yeah, out-of-band payments, that's the word for it. Do you guys think about that at all when you're designing mempool algorithm stuff? Or is it just
I think it's our biggest enemy.
Okay.
I think it is among the top contenders of the biggest threats to Bitcoin in the short to medium term. Because development of reliable payment rails of transactions to miners directly makes it harder for new miners to enter the space, because it's just such a centralizing force where, okay, there's a service, everyone submits their transactions to it, and the biggest miners get it from there, and you just can't beat the efficiency of the centralization. And I don't think this is necessarily a problem. Like, our goal should just be building something that is good enough that there is no real reason to go beyond it. But I do worry that if things get developed where, you know, a substantial portion of miner revenue comes from out-of-band payments or privately relayed transactions, then you basically cannot enter the mining ecosystem anymore in a permissionless way.
Right.
Like, you'll need to interact with the services that do the transaction relay, and
that's a centralizing force.
Yeah,
that's
exactly.
like a central thing. And then as soon as you get one of those, then, you know, like, what's it, OFAC or whatever, someone can knock on their door and be like, these transactions aren't allowed.
Like the whole, like the entire reason why Bitcoin has proof of work as opposed to a traditional distributed consensus algorithm where, you know, if we're okay with these 5 miners today who hold the majority of the hash rate, like, why don't we get rid of proof of work? Just give them a key each and say, whenever 3 of you sign, it's fine. Like, if we're okay with that, then proof of work is entirely pointless. And of course, the answer is that over time, like, sure, it's true that there are only a few mining pools, and I'd certainly prefer to see that more decentralized too. But it is still the case that the set of miners, the set of pools can and does change over time.
Yeah.
And today you can still enter the mining business without asking anyone in the world for permission. And I worry that if it comes to a point where transaction distribution from wallets to miners doesn't go through a public network,
True.
then this is a property that gets worse.
Definitely, yeah. So does Cluster mempool, you think, help with fixing that, or is there like another project?
I think it addresses a small part of that. Namely, I don't think what it improves is really the most important part there. As I said, the primary reason is this, you know, or the motivation was the fact that we just make completely wrong decisions at some time. And that's the primary goal to fix. But it is the case that this ties into it. Like, if more complicated transaction patterns, like things more complicated than CPFP, say children pay for parents, where you have 2 children that both bump the same parent. Like, I'm sure miners would like
both
to be able to be, well, they'll get both of them. But the point is, like, okay, you have one low fee rate transaction and you have 2 high fee rate children that spend an output from it. Both should be treated as increasing the effective fee rate of the parents.
Yeah.
And the algorithm in Bitcoin Core today will only consider one
at a time, right?
Yes. And of course, as soon as one, like the parent and one of the children, English is hard. One of the parent and one of the children is in, now the second child may be considered too, but it won't be considered until it's quite possible that with the 2 children together, the parent would be bumped far higher than it would be with just one.
And
it might be that one is just not enough to get in the next block, but 2 is. And so if such patterns were to become commonplace, I'm not too worried about this, because this probably it's a chicken and egg problem. Like, if miners can't detect the pattern to make use of it, then probably people won't build use cases that rely on it. But if it were to happen, then like, ultimately the peer-to-peer network, if it wants to remain a reliable way for transactions to get from wallets to miners, it needs to be able to make decisions about the incentive compatibility of the transactions involved, even when those are complicated.
Yeah.
And Clusterme is about having a framework to reason about that close to optimally. And so its goal is not really to increase miner revenue or to make miners like take advantage of these patterns that might emerge. The goal is to make every individual, to level the playing field so that every node in the network can reason just as well as the miner in the end.
Right.
And that with that comes also having a reliable mempool, which includes transactions that miners want.
Right. Yeah, that makes sense. So, I mean, the real goal is to make sure that the transactions that you're relaying through the network are the ones that miners are going to want to put in their blocks.
Yes, and this it cuts like by being a public network, there are constraints. One of them is it is extremely vulnerable to denial of service attacks.
Right.
Like there are just there's a limited amount of bandwidth. Like it, we want to prevent the case where someone just creates a transaction, changes the signature, changes a tiny bit, sends a new one, and does this millions of times. The network cannot relay millions of transactions. The way it works today is sort of the denial of service protection philosophy behind the Bitcoin Core mempool design is, well, transactions pay a fee. And if transactions pay a fee, they are not unlimited. But that, of course, only works when the transaction is actually getting picked up by a miner.
Oh.
And so we want to avoid relaying transactions that won't be picked up anyway. But at the same time, you do want to relay all or most or close to all that will be picked up, because otherwise you may end up with a situation that there's a certain subset of users that make transactions that want to pay a fee and that don't make their way to miners. And now when that happens, mempools become less reliable, and we're again to the problem of incentivizing private relays of transactions to miners.
Right, makes sense. Are there any things else that, like, so Clusterme mempool is going to try and make it so that when you're sending a transaction, the transactions that you're relayed are the ones that a miner would want at the end, right?
Our best effort in getting that, that's hopefully good enough.
Is there any other protocol changes or projects that people in Core or maybe even outside of Core are working on that would improve the what do you call it, the ability for mempool to stay like a public mempool, or is Clusterme mempool most of where people have their focus right now?
Well, there are a number of related things. So there's certainly package relay.
Obviously, yeah. Okay.
So the problem there is we already talked about CPFP, where you have a low fee rate parent and a higher fee child that tries to fee bump it in the hope that it will be considered together. But what if the parent has such a low fee rate that it doesn't propagate at all on the network? Not just won't be picked up, but it is so low that the network, when whatever its denial of service protection rules are, decides I can't relay this.
Right.
And so package relay, this has been Gloria Zhao's project for the past couple of years, and that I think will make more progress after Clusterme mempool 2.
Cool.
Is making this packaging of the parent and the child together not just work at the mempool and at the block building layer, but directly in the transaction relay protocol. Because today, or until very recently, because some improvements have been made there in a recent release, the parent would be relayed, the receiver would say, this is too low fee, go away.
Right.
Then the child would be relayed, would be like, oh, I don't have the parent. Give me the parent. Oh, here's the parent. Well, that's too low fee. And so it would never ever get to the point where it had both a parent and a child together. Right. And so it never gets considered. For very simple cases, that is now improved. But with more explicit package relay support in the network, these could just be treated as a group and relay together and be like, here is a parent and a child, and you, yep, paste.
Yeah, definitely.
Looks good.
Could we rename like package relay cluster relay? Would that be like a wrong misname, like a renaming?
It wouldn't match how we're using the terminology, because a cluster is a set of related transactions. So to give the most extreme example, you could have a set of parents transactions and a set of child transactions that each like depend on
multiple parents.
Yeah, each like you could have like a trellis where you
Got
have like
it.
a parent child,
Yeah.
parent child, parent child, parent child. They're all one cluster.
Got it.
And this does not mean that they all necessarily need to be relayed together, because even within a cluster, you can have higher fee rate parts and lower fee rate parts. It is more.
That's
so where the name cluster mempool comes from is our realization that so in the cluster mempool implementation, what we're doing is the core idea, I think, can be summarized as, instead of running the mining algorithm at block building time, we run it at transaction relay time.
Interesting.
We pre-compute the order that the transaction. We don't actually mine a block, obviously, but what we get from running this algorithm is an ordering in for the transactions.
Cool.
To see which ones are better than others. And our observation is that unrelated transactions don't interact. You really only care about the ordering within a group of transactions that are related. If you have multiple groups of transactions, and to be clear, 99% of all transactions are in a group of one, because they don't interact with anything. But still, they're a group, they're clusters. So we call these the clusters. And now, anytime a new transaction comes in, or something gets mined, or something gets evicted, that results in a cluster changing, we rerun the mining algorithm just on that cluster.
Cool, okay.
And this is actually sufficient to very quickly aggregate things across all clusters. If you now want to build a block, so we don't really pre-compute an ordering over the whole thing. We just pre-compute it per cluster, but that's enough to, at block building time, just find the best parts of each quickly. You want to evict something, drop parts from the end of things. You want to. So another example of where a heuristic that is really an attempt at capturing transaction quality happens is flood protection. When there is a burst of transactions on the network, Bitcoin Core will rate limits the extent to which they're sent out.
Okay.
Has been doing that since forever.
And this is kind of an attempt to prevent denial of service, right? Okay, yeah.
You don't want to overload your peers.
Right.
This also interacts with the privacy thing.
I see.
Because we
you
buffer.
can tell where the flood comes from?
Not quite, but we buffer up transactions and then send them out in a different order, potentially, to hide the order in which we've received them.
That's cool.
But this flood protection mechanism, if there's suddenly a burst of many transactions coming in, then we need to make a decision of which one to send out first.
Right.
And today that happens first by ancestor counts.
Okay.
So things without dependencies go first, and then they're sorted by individual fee rate. But really what we would want is just to sort them by the order we think they'll go in a block.
Right.
Because those should be going first. The cluster mempool would just know this.
You would know. That's cool.
And today we just can't do that, because the way to compute that would be to build a block the size of the entire mempool, which would take... It's not impossible to do, but it's just way too slow to do for every individual transaction relay decision. Other ones are BIP 125 replaced by fee.
Yeah.
Like a transaction comes in, it conflicts with another one. It looks like it has a higher fee, but it conflicts with some other things. How do you decide is the new situation better from an incentive compatibility perspective than the old situation? BIP 125 has a number of rules that try to make sure you only accept things that are better. It's wrong. There are examples where it will accept things that are just unambiguously worse. And it will reject many things that are unambiguous.
Cool. Okay, so like we're talking about all these changes and that's happening in the mempool, and you were saying that RBF, you really doubt that wallet developers currently use any 125 heuristics when they're making RBFs. Whenever these changes ship, so first maybe we can come back to like when should people expect this coming out, but what kind of like action should wallet developers, people like who are working on Lightning implementations, like projects that are using the mempool for stuff?
What should they know?
What should they know? Yeah.
I think the biggest change that people will see is the ancestor set and descendant set limits going away, and they being replaced with a cluster size limit.
Oh, okay.
Of 64. Those who don't know, currently the Bitcoin Core mempool implementation has a limit of, because it pre-computes ancestor set and descendant sets, which is the set of all unconfirmed transactions that a particular transaction depends on, or all that depend on you, and that is limited by default to 25, which in some cases means that, I don't know if that still happens, but in the past, I know that there have been people who suffered from like, I want to make a chain of payments. I have a single UTXO. I'm paying person A and change back to myself. I use the change to pay person B, change back to myself. I use it to pay person C, change back to myself. You can only do this 24 times.
Right.
Because the 25th time, well, it becomes a 26th transaction, and it's not illegal, there's no problem with it, but it just won't be relayed until the first one is confirmed. Of course, the correct answer to this is batch them together and do a single transaction, which I think is largely what has happened over the past few years. But there are probably people who still have code out there to try to avoid that. So that number will go up in practice to 64, probably, with Clusterme mempool, because we're dropping the ancestor set limit, we're dropping the descendants size limit, and it becomes a cluster size limit. Now, that is a limitation of a different nature, though it is qualitatively similar to a descendant set, in that if I pay you, and you now want to make 25 payments with that, well, you can only do 24. Once you've done 24, I can't use my change anymore to send any, because there are 25 already. That's already the case today. And
interesting.
A cluster sub limit does something similar but it's wider, because now I can pay you, but someone else can pay you too, and you use those to pay someone else. Now, everything that they're doing is also aggregated in this. We did run simulations. Suhas did. He created a log of historical peer-to-peer activity.
Cool.
And replayed what would change if you were to run it in a Clusterme mempool code, and the result is very little changes. But it is a bit hard. Well, part of that is because almost all transactions are single transactions, and of course we can ignore those. Those are obviously not impacted by anything. But it's also hard to predict how the ecosystem might respond to this, and it's like using historical data to predict how people will be impacted is of course the best we can do, but it is an approximation, because it's quite possible that behavior changes in response to this too. And even in cases where simulations show that people were doing something that won't work anymore, that does not indicate a problem. like it just means those transactions can happen at the same time. But
Right.
it doesn't mean anyone was actually relying on that happening.
Right. Yeah, cool. How much? Yeah, I mean, I think we should probably wrap up soon because I don't want to take too much of your time. But when can people expect Cluster mempool? Is it like this year, next year?
Our goal is to get it merged in the next Bitcoin Core release 30.0, which
That's
would
good.
be released in October this year if all goes well. Of course, actual adoption on the network, who knows? That can take some time.
By adoption, you mean people upgrading their
Yes.
version of Bitcoin Core to the version that uses it? And about like what percent of adoption would you expect before the effects get seen on the network? Does that make sense?
You probably need somewhere in the order 10 to 50%. I think that's a wide range, but it's hard to say. Like you'll get some of the effect as soon as there is a reliable path of nodes that all have it, but like it's not supposed to be a hugely impactful change, right? It like I don't expect anyone. No, well, these ancestor set and descendant set limits are one thing, but it goes up. So I don't think of this as a big upgrade to the network. I think mostly of this as just an improvement in how Bitcoin Core does decisions for what to relay, what to evict, block building, and so forth.
So it's more like a improvement on existing stuff, and so shouldn't have too many impacts on the user experience of relaying transactions. Super cool. So you're going to be talking about mempool, cluster mempool tomorrow at bitcoin++ in the morning. I think we have you at 11:30 Central Time. So if you're watching this and want to watch Pieter Wuille live giving his presentation on cluster mempool, tune in to our live stream, which we'll have going. Super excited to have you here.
Great to be here.
Yeah, thank you. Oh yeah, handshake. Cool. Thanks for coming. Cool. All right, thanks, Pieter.
Yeah, that's good.
That was amazing. Thank you.
It was really well, yeah.